Hey guys, hello and welcome to online stats class, Math 1342. Today we're going to be looking at chapter 9. In chapter 9, we have two sections, 9.1 correlation, 9.2 linear regression. So let's go ahead and see what we have in section 9.1, which is completely defined to correlation. Now let's go ahead and see what the objectives are. The objectives for section 9.1 is we're going to be introducing ourselves to something called linear correlation. We will talk about independent and dependent variables. We will talk about types of correlation. We'll be looking at different types of correlation here. We will look on how to find a correlation coefficient and also test the population correlation coefficient using a table. All right. So what is a correlation? Correlation is a relationship between two variables. So that two variables could be X and Y, it's a relationship between two variables. Now let's go ahead and see what the next one is. The data can be represented by an ordered pair, X, Y, and X is your independent variable, or it's also called as your explanatory variable. There is a question on this on your homework, so you might want to take a note of what it is. And Y is your dependent variable, and which is also called as your response variable. So what that means is you have two variables here. One is your X and the other one is your Y. And you're trying to see, does Y depend on X? If so, how does it depend? In this case, we will be only looking at linear correlation. Are you guys familiar with the equation Y is equal to mx plus b, where X and Y are your ordered pairs, and you try to see how Y depends on X? So in your correlation, where X is your independent variable, Y is your dependent variable, your X goes on X-axis, that's why it's independent, and your Y goes on Y-axis. So you're trying to see how Y depends on X. So is it increasing if it's going up, or if it's going down, is it decreasing, or is it a constant? We will look into various cases. So keep in mind, X is your independent, Y is your dependent. All right. So how do we graph this X and Y plots? So the name of the graph that you use to graph is called a scattered plot. So it's your X-axis and your Y-axis. This is your X, this is your Y. Let me name it X, and this is Y. And you go ahead and plot different things. It's scattered plot, and depending on the shape of your plot, you do see if it's going up, going down, if there is a correlation or no. So let's go ahead and take a look at the next one. The independent variable X is measured on horizontal axis, which is your X-axis, and the dependent variable is measured on your vertical axis, which is your Y-axis. A scattered plot can be used to determine whether a linear, when you're talking about linear stands for a line. Linear is nothing but your line. Correlation exists between two variables. So what does that even mean? Let's look at it. I'm going to go ahead and take my box tool here, and you will see that this is a negative correlation. When you see a negative correlation, do you see what's happening here? The graph is going down. When you move from left to right, your graph is going down, so it's negative. And this one here is a positive correlation. This is a positive correlation. So when I'm going from left to right, what's happening to my graph? My graph is increasing. That's a positive correlation. Now look at the next one. I don't have anything here. I don't know if this is going up or going down or what's happening here at all. There's no direction, so there's no correlation. Now when I look at something here, there is a shape. Do you see a shape? Yes, there is a shape. This is a parabola, inverted parabola, but this is not linear. So I'm only looking for lines going up or lines going down. So this is a correlation, but it's a non line correlation. So I'll name it as a non-linear correlation. All right. The next thing is correlation coefficient. That is the measure of the strength between your two variables. What does that mean? It's represented by a symbol R, which stands for correlation coefficient, and this is the formula. So you're not going to be using the formula, you're going to be using StatCrunch to go ahead and find your correlation coefficient. So let's go ahead and see different examples of a correlation. The correlation coefficient is represented, R represents the sample correlation coefficient, and rho represents your correlation coefficient, the population correlation coefficient. So R is for your sample and rho is for population. Keep in mind, R is for sample and rho is for population. All right. So the range of correlation coefficients is from -1 to +1. So it is from -1 to all the way to +1. And there is a 0 in between, of course. So let's go ahead and see how this works. So if your R is negative, that means it's a perfect negative correlation. You will see a straight line going down. If your R is close to 0, which is your correlation coefficient, then there is absolutely no correlation. It's all over the place. It's scattered. If R is equal to 1, there's a perfect positive correlation. And keep in mind, R is a correlation coefficient of the population, where rho is a correlation coefficient of, R is a correlation coefficient of sample, and rho is a correlation coefficient of your population. So right now you're looking at R, which is sample, and rho is population. So here you have different examples of correlation coefficients. This is a perfect positive. So look at how the graph is. The graph is going all the way up. This is a strong positive. So it's definitely, when you look here, this is definitely not as straight as the previous one, but it's still going up. So it is still positive, but it's a strong positive. Do you see that? Look at the correlation coefficient. This is 0.81. When you look at this one here, it's definitely a positive. I see it's going up, but it's not as strong as the other one, which is this right here. But even if you look at your correlation coefficient, it's 0.45, which is a weak positive. And let me scroll this up. This is a perfect negative correlation, right? This is also a negative, but not perfect. It's a strong negative. This is absolutely no correlation. It's all over the place. It's everywhere.